Good morning, everyone. Welcome to the webinar from TriStar. My name is Thiagu Palaniappan. I work for TriStar. Today's webinar topic is going to be on Creo Simulation Live, the new extension that was released in Creo 4, as well as the simulation extensions, right? The older Creo Simulate extensions. We'll just do a quick overview on that. Just a quick note here, there was a handout section in the webinar area that you might want to download, and it might help you kind of understand. It's just a data sheet on Creo Simulation Live. That might help. During the presentation, all of you will be muted. So if you have any questions, feel free to start typing in the questions area, and I'll try my best to answer questions towards the end of the presentation. Those are not familiar with TriStar. We are one of the largest resellers, value-added resellers for PTC products. We are a company that helps manufacturing companies adopt software systems and processes with best practices, training, implementation to help to allow a better and more efficient product development, right? And we are headquartered in Phoenix in Arizona, and we do have our team spread across the United States and Canada. And we pretty much help out with PTC softwares like Windchill PDM Link. We also have some automation solutions, as well as CAD, FEA, as well as MathCAD and some of the other products that we support, right? So before we begin, a real quick note about a time-limited offer that will end the end of this month. So if you want to take advantage of that, there was a 35% off on Creo Simulation Live. You know, pretty much all the extensions of Creo, I would say, are 35% off. And in this webinar, we'll specifically go over Creo Simulation Live and Creo Simulation Advanced Simulation Extensions, their capabilities, and we'll go through some examples as well. If you would like to take advantage of it, just please reach out to your reps or visit us at tristar.com. Thank you. From an agenda standpoint, I wanted to just go over a high-level overview of the current computer-aided engineering solutions inside of the PTC product line that is integrated to Creo. And then we'll specifically go over Creo Simulation Live, which is based on Ansys technology. Ansys Discovery engine is kind of what's working behind the scenes on Creo Simulation Live, as well as PTC's own P-Solver, native P-Solver, used to be called Pro Mechanica back in the days, currently called Creo Simulation. There are a couple of extensions there. We'll also go through some of the benefits of using that. So two products mainly we'll cover here. First off, as of today, if you look at the current Creo Simulation portfolio or the options available for customers, we do have the old Creo Simulate, the Creo Advanced Simulate, which used to be called Basic Mechanica, Advanced Mechanica. Very much they're very powerful. There are different, depending on their capabilities, which I'll go over in a little bit here. There are a couple of extensions there. But starting Creo 4.0, PTC started partnering with Ansys to take advantage of some of the new real-time simulation capability instead of the Discovery product line there from Ansys. So Creo Simulation Live is powered by Ansys. There's also a new one they released in Creo 7.0.2.0 called Creo Ansys Simulation for much more higher fidelity, much more of a mechanical solver-based, Ansys mechanical solver-based analysis tool. And then you got Creo Flow Analysis for high-end CFD, as well as generative topology optimization. So these are kind of purchasable extensions. With your base package, there's some light capability that's included from Creo Simulate, but for the most part, they're all add-on extensions there. So mainly I thought of focusing in this webinar on Creo Simulation Live, as well as the Creo Simulate capabilities. We'll go through some comparison charts. What are the use cases and things like that. And before that, I also would like to quickly go through some of the barriers that currently we have in doing a true simulation-driven product design, right? So we'll go over that. So in my experience being in the industry myself for the last 20-25 years, as well as working with customers and companies that we consult with, we all know that pretty much, all companies, if you think about product development companies in general and their teams that we speak to every day are pretty much striving to achieve the improvement in these areas that I've listed here, right? They want to have a better understanding or a deeper understanding of the product performance, right? That would perform in the field, for example, right? That'll help shorter development cycles and quicker time to market, leading to reduced design cycle times. They want to have fewer prototypes and first-time quality at reasonable cost, thereby reducing warranty, liability, and exposure, right? So this is kind of what we're all trying to achieve working for a product development company, obviously. But before we, show you the product, I want to just take a quick look at the typical product development process and where we might be able to make a genuine improvement, right? So what I'm showing you here is something that everybody should be comfortable with, and I've just given a generalized overview of the traditional product development process, right, that you see here from different stages, from concept, design, simulation, prototype, and then manufacture, right? So that's the typical stages that we go through. Now, for many years, industry has tried to consistently use simulation as part of the process for all the reasons that we talked about in the previous slide. Unfortunately, the fact remains that when simulation is used as part of the product development process, it's used exactly as you see it here, right? It's almost a final validation step after the design is practically complete. So that is not the original vision, right? That is exactly not the vision of simulation, of true simulation-driven design that the industry has been striving to achieve for years, right? And why is that, right? What are the barriers to simulation being used every day throughout the development process by design engineers, for example, right? I understand some of you may be experts, but for design engineers, what are the barriers, right? So first of all, if you think about it, right, often, I myself have been in different roles during my industry days as design engineer, as project engineer, as well as an analyst. So I can kind of give you my little thoughts here. Often engineers feel like they don't have the expertise they need to run simulation while they design, right? They feel like they need to consult an expert that they may not even have access to, for example, right? Some of your companies may even farm out your FEA to an outside consultancy firm, and they give you results, or maybe you have an expert that's already busy with a lot of other simulations on his plate. So and also there's that so-called expert, right, who's supposed to be an expert in FEAs. Initial task, most of the time, more often than not, is to figure out how to simplify a copy of the model, right? So that's typically what happens, right? They cannot use your design model that the engineer is providing. They may have to create a simplified copy so it can mesh quickly. And ultimately, the goal is to have the simulation run in reasonable time, but still provide an actionable answer. And typically, engineers don't feel comfortable making that judgment, right? And these are some of the barriers, right? And additionally, we all know that design process, as always, is an iterative one, right? So it's absolutely the design engineer would want to use simulation as it evolves through the design through all those iterations, but this would require running simulation that could take hours on multiple uniquely simplified copies over and over again, right? It's just not efficient in my view, right? It's too disruptive to the design process, and so design engineers generally just don't do it, right? So that's so with that said, PTC and Ansys partnership was really meant to solve that problem that I just mentioned earlier, right? The goal is to make sure that that product development teams need access to an analysis tool that reinvents the way simulation is used within the product development process, right? The tool must be so fast, so responsive, and so easy to use that it can literally keep up with the engineers while they work, right? As you make those design changes and try to improve your design, right? No copies, and you're not going to be waiting, right? Just instant access to the simulation results, allowing engineers to rapidly explore and create better designs, right? So PTC's partnership with Ansys essentially makes this a reality. when you have two of industry leaders, right? One has been the leader in CAD for 30 years, PTC, right? And then Ansys, as we all know, has been the golden standard in the simulation world, with 45 plus years in the having experience in engineering simulation with all sorts of physics that they support, right? So it would be nice to have to put that Ansys power at the hands of the Creo design engineer while working on the design to do true simulation-driven design, right? And for that, those are the two products, which is Creo Simulation Live, and then there's also a Creo Ansys Simulation. We'll mainly focus on Creo Simulation Live, that gives you instant feedback. It has structural, thermal, modal, as well as fluid study, right? You can also do some basic fluid flow analysis. And the good thing is it has your familiar user interface. It's completely integrated into your Creo Parametric environment, right? So in starting Creo 4.0 MO90, PTC introduced this Creo Simulation Live, and then they have two products that are Ansys powered. One is Creo Simulation Live, the other is called Creo Ansys Simulation. Both have its own purpose, right? The Creo Simulation Live is more for instant, quick feedback. It's more of a directional tool for the design engineer, wherein as he's working on his design, he or she would like to get quick feedback in real time without having to mesh the model or having to wait or having to solve it, right? It leverages the GPU, your graphics cards, right? So there's a graphics card requirement, obviously, but it gives you instant feedback, allowing you to make rapid changes or improve the design without having to do simulation at the final validation step. Now, having said that, you might still want to have a high fidelity, higher accurate simulation tool that would give you some more additional powerful capabilities than Creo Simulation Live, and that's Creo Ansys Simulation. Maybe you want to do some assembly level analysis that's simply not bonded. You might want to add some joints in there, some degrees of freedom. You might want to refine the mesh and use a traditional CPU-based computing and maybe do some large deformation analysis. Those type of analysis can be done in Creo Ansys Simulation. So really two tools here for the different audience or based on who would like to use it and at what time in your design process, at what time, would you like to do a final validation with a higher accurate solution, or do you want to do just some upfront quick FEA instant feedback during the design process itself, right? So those are the two solutions there. And they both allow, structural, thermal, modal. And then Creo Simulation Live, starting Creo 7.0, you have fluid flow simulation there, right? And like I said, it's mainly leveraging your GPU. So instead of the traditional CPU, you don't even have a solve button. You essentially show the results once you set up the analysis. That's how quick and real time the feedback is. And it works in Creo 4, Creo 5, 6, or 7, and even the latest 8.0, which I forgot to mention there because 8.0 is released now. So starting Creo 4, you'll be able to use Creo Simulation Live. But if for using fluids, you would need Creo 7 or 8. Structural, thermal, and modal are supported in 4, 5, and 6. Just some of the license options we have. So there are two extensions with respect to Creo Simulation Live, Creo Simulation Live and Creo Simulation Live Plus. The Creo Simulation Live allows you to do structural analysis, thermal, and modal, right? You want to get the natural frequency, for example, and the mode shapes. You're able to do that with Creo Simulation Live, get instant feedback, quick update, reports, etc., right? As far as fluids, if you want to do your fluid domain creation, you want to do internal flow, external flow, add some thermal conditions and temperature as well, then you would need Creo Simulation Live Plus, which is applicable only starting Creo 7.0. So there are two license extensions for Creo Simulation Live. Okay. So let's take before we move further in the presentation, I thought of going through a quick example on Creo Simulation. So in the initial first half, I thought of showing you Creo Simulation Live, and then the back end of the presentation, we'll get into the Creo Simulate extensions. So first off, I'm going to open up, it works on assemblies and parts. I have a very simple assembly here. I'm taking the role of a design engineer that's probably not even experienced in FEA, but wants some direction as he designs, right? So let's say right now I'm in the process of designing this support bracket or this part that needs to support this component in my assembly there. And I'm looking at my model tree here, and I do have some concept. I'm at my concept stage pretty much, right? I have some shapes in here, shape 1, shape 2, shape 4, some external sketches, and I'm doing my regular Creo Parametric modeling here or design work where I'm thinking, okay, let's just see if this shape might work. I'm just going to go say, I want you to extrude up to that surface. I'm using my regular design tools in here, a simple extrude that I'm doing here. And at this point of time, where I've not even done my fillets or ribs or anything yet, I'm not even done my mounting hole locations, and nothing is done. I'm just in a very basic initial stage of my design. I'd like to get some feedback, right? It'll be nice to get some feedback. It's almost like, in Microsoft Word, we do have the spell checker, right? Why should CAD be different in my view, right? For CAD also, what would be the spell checker, equivalent spell checker capability in CAD is a quick simulation of the part giving me that confidence that I am moving the right direction, right? So that spell checker is kind of what I'm going to show you now inside of Creo, which is Creo Simulation Live. It can be done in parts or assemblies. Right now, let me open up this part. Right, we'll first show you parts, and then it also works in assemblies. Actually, if it's bonded or welded, it works pretty well. If it's contact, then you may have to use Creo Ansys or Creo simulation extensions of the advanced extensions. But right now, what I have is that same part, and that spell checker that I keep mentioning for CAD is this Creo Simulation Live. So it's right now activating that Simulation Live libraries for me. I didn't even go to a separate application, right? It's right inside of, if I go into the part right in here, it's right inside of Creo Parametric. I'm able to go to my modeling environment, and I'm really not going into a separate application even. I'm not even going to applications and invoking a separate app. It's not like an app switcher. I'm just right inside of my Creo. I'm just switching to live simulation. That's really what I'm doing here, right? And I'm able to add multiple studies, either a structural or a thermal, modal, or a fluid study. For this, I just probably want to just see, what happens if it's constrained at the bottom, right? It's fully fixed at the bottom here. I just fully fixed it. I use my mini toolbar, maybe assign some forces or loads in here. I want to assign a quick force, depending on my triad. My triad is showing y-axis up, so maybe if I give a vertical load down here, maybe we'll assign a vertical load up there, right? And depending on the unit system you're comfortable with. And of course, I have the material, right? It's already assigned in here. It could be from your Creo library, or you can create your own, right? And that's it. There's no solve or define analysis or run right in here, right? There's not a single run button here. All I do is just click on this icon right here, and it's essentially going to be running the showing me the results. Now, when I say results, it's going to give me a colored plot of the stress and the deformation. I didn't even have to do the mesh. So this is when the Ansys Discovery technology is kind of working behind the scenes. Ansys came out with about 3-4 years ago a product called Ansys Discovery Live. Many of you may have heard about that. So that's the technology working behind the scenes here, right? That's the engine that's making this work. So immediately I get like, okay, there's my von Mises stress. Maybe I would like to know in a specific unit system, right? That's now, I'm not yet done though, right? I'm still need to make some changes. I'm just, in an exploratory stage right now. I'm in an ideation stage of my design. At this point of time, it's telling me that the max stress is, 15 megapascal right in here. Of course, I could say, show me where the maximum is. There it is. It shows my max and minimum right up there. I could probably even add a little probe in there for my design. I could just say for the entire model, show me where the maximum is, right? So there it is. It gives you a little probe in there. So there is a max stress. I'm just going to save that measure right up there. It's just like adding a little probe for me that'll keep track of as I'm making my changes in here, right? I can also ask it to accumulate the data because I might be making some changes. Right now, if I look at this, I'm at my first single design iteration or maybe change that I did, right? That's really what I did so far. Now, as I can go back to my modeling, right? I'm just in my regular design environment where I'm creating my features, editing them, and I still have the results overlay on top of my design. And I'm thinking instead of this design, maybe I would like to redefine that and maybe use the second shape, which is shape number 2, right? I just switched that. As soon as I'm done with it, seamlessly the software or simulation kicks in, right? The spell checker that I kept mentioning, it's telling that, okay, you made the change. It goes back to blue. It runs it in real time, and it tells me that the stress is now obviously higher, right? You can see that it's now jumped up to 59 up here in the spectrum, as well as in my if I look at my graph here, I have 2 design points in here, right? That's the first, that's really small, 15, and now it's really jumped up. So this is not going to work, I'm thinking, right? I'm going to say, okay, let's go switch it to shape number 3, right? Maybe I'm just saying which one. So this, like I said, it's a true directional tool, right? Just give me some direction. You know, I understand this may not be 100% accurate, or it's not going to be as accurate as if I were to send it to an FEA, but at least it's close. It's within 10% typically, right? So it kind of gives me that confidence with the Ansys technology working behind and telling me that, okay, you are going the right direction or not. So now it's come down, it's 17, right? I'm still not happy with it. I'm thinking, what if I choose a different shape in here, right? Maybe this guy here. And as I'm making that change for each of those changes I did, I was just in my regular design engineer mode, if you will, right? You know, wherein I'm just creating features, editing them, and each time I'm not having to even go back and rerun the analysis, right? It's just updating it in real time. So this is a huge advantage of Creo Simulation Live, right? Compared to the traditional CPU-based FEA that we have seen so far, right? Which may be more powerful in certain aspects, but for that initial direction, it's huge, I think. So now it's jumped up again, right? So I'm thinking, you know, maybe the first one that I used probably was 15. Maybe that is the lowest one. Maybe I should just go back to that, right? And then see further if we could improve it, right? So I might compare this with my yield strength of the material, right? I might want to have a good factor of safety. So all that you would typically do in FEA, that applies here too, right? I'm looking at I'm going back to my initial one there, and it's what it was like 15 or 16 right up there. It is still the same, as you can see here, and I'm able to look at my graph, and then it kind of gives me all my different points, right? It kind of gives me, okay, these are the different things I tried out, right? It's almost like gives you a history of all the changes I did and how the stress keeps going up and down for each change. And now that it's showing the high stress here, I'm thinking we might be able to eliminate that or reduce that stress by adding a round, right? Makes sense. If you add a fillet in there, maybe it's going to help relieve the stress. I just created a quick fillet. I went into my design, and I clicked on the edge, created a round. Once I'm done with the feature, the system automatically puts back your analysis results, right? So when it goes to blue, it's really thinking, right? I have a GPU with a video RAM of 4 gig. I'm talking about the GPU video RAM itself. PTC recommends 8 gig, so I'm sure if I'd used 8 gig, it's going to be a lot more faster. But you know, you can control the, you know, there's a performance option where you can say the higher. You can say I want to have more accuracy and less speed. There's a slider for that, but right now I just left it default in here, and it's come down a bit, 13, right, with that. But still, I'm not happy with it, right? I could probably go and say maybe I want to add a few more features in here. I might want to go and say, you know, with Creo 6, I like these new mini toolbars right within the design tool itself, within the feature, where I want to probably go for, let's see here, a smaller size there, and maybe a larger. I just added a quick chamfer with the D1, D2 size, and immediately I've added material, so that should help reduce the stress, at least at that location, right? So the thing is the quickness with which I'm rapidly able to make changes, explore the design at the same time. It kind of gives me that quick feedback. It came down a bit, but I'm still not happy with it, right? Probably I want to get it below 10, right? Let's say my yield strength of the material is, let's imagine it's 20, and then maybe I want to have a factor of safety of 50%, so it should be less than 10. That's what I'm trying to strive to achieve here. And this is when I might say, okay, let's go see if a rib might help, right? Most of the time, if you add more, it's going to be a little more stronger there. So I'm going to just see, let's see if I could use one of the datum planes here, and I'm going to go create a quick, let's just select some references as I'm sketching here. I'm going to just use the Alt key, grab some references real quick. And ribs require an open sketch, so I'm not going to close it. And I'm just going to give it a specific thickness, and I'm done with it, right? So that's one rib. Maybe we could pattern it, but we'll see what this does, right? So it's going to increase, decrease. I know I didn't add any rounds or fillets or anything around it. As expected, that corner is where it seems to be high now. It's actually jumped up to like 17 here, right up there. It's updated that too. So if I look at my, data here, right? We went up here, we tried those different options, and then we're trying to reduce it. Now we're again back up here. It's nice that how it gives you those, it's captured that data, right? Now I'm thinking maybe I should probably pattern this guy, right? So maybe create a few more. So I'm going to go, let's say I want to go and use a direction pattern, right? We'll just use maybe a surface or a datum plane, and we'll say we want to have about 3 of them, right? Once I'm done with those 3, now, as you can see, again, it's now, whenever it goes back to the blue color or the fringe plot, it's essentially redoing it, right? Behind the scenes, in real time, the GPU is kicking in, and it says, okay, now looks like I've gotten it right exactly at 10. I'm thinking maybe it should still be a little bit lesser than that. And what if it looks like that this is working, so I'm going in the right direction, and maybe I should probably just make it a little bit larger, I'm thinking, right? Let's see what it does, right? All these are some common sense design changes that you might do for a new design or based on your prior experience. But it's nice to get that validation or that from Creo Simulation Live that yes, the stress is going to be this much, or the deformation is going to be so much, right? Are able to check it, and looks like we got it to like 7 megapascal. And so if you look at my the history, right? Yeah, we started here, and then we went up, we explored a few things, and then we started going the right direction. And I can keep doing this, right? A little more, but I'm thinking I'm at a good point now. So for this design, right, I can turn off my simulation right there. I can get back to my assembly here, and I can do maybe a full-fledged assembly FE. Now that we know this part is going to work, right, we can probably do a quick mirror of this, right? I should be able to mirror it off of the one of the data planes in here, right? I should be able to preview that. And it created an analysis or a part on the other side. I just did a left-hand side, right-hand side type part right up there. Now I should be able to run an analysis on the entire one too, right? I could constrain it here. I can do the same thing. It works in parts and assembly. So that's just a very high-level overview of Creo Simulation Live working on the structural side. Now, what about modal analysis, right? There might be situations where you would also want to do, let's say, a frequency calculation, right? So let's say I'm working on this valve cover, right, in our team, and it used to be a casting maybe, and now our engineering is thinking about, okay, should we switch to a more of a plastic component with a different material? But for then, we got to think about the frequency, right? The natural frequency and the mode shape, right, of this design when we switch material. So I'm going to be using Creo Simulation Live for that, and I'm going to go and again, I'm going to live simulation, right, of that cover part. And right now we have a couple of materials in here. One is ABS, and I got 2 materials in here, aluminum and ABS. If you see here in my library, I've added to my model aluminum, and let's say I want to set that as the master, or that is what I'm going to assign right now. And based on how it will be constrained on the gasket, maybe where it's all those surfaces, I might want to fully fix, right, the contact surfaces there. So we'll just grab these surfaces and say I'm going to fully fix that. There it is, and that's it, right? It's going to be a modal analysis. So what I would do is, I want to go start with a modal instead of a structural. By default, it picks up a structural analysis right in here, and I can just go to my fixed constraint, and the default was structural. So the constraint that I added earlier ended up being a structural one. So I'm just adding that back on here. There it is. And I have the material, and again, just like before, like for the structural nouns, I'm going to just say simulate or show me the results. And it's again using the GPU. If I look at my task manager right now, it'll be using GPU, and what percentage of the video RAM you can use, all those can be controlled. There are some options to control, right? Should it be using 100% or 50% or 20%? But since I'm doing a demo here, I've just kept it lower, so it gives me a real quick feedback in here. So there it is, right? It's telling me that the mode 1, right? If you look at it by default, it has picked up 6 modes, and the mode 1 is right around 900 hertz, as you can see, the natural frequency right there with ABS, right? And I'm thinking, you know, what happens if I switch it to with aluminum, actually, with aluminum 2014? I'm going to switch it to ABS, and as soon as I switch, you're going to see this the color spectrum go back to blue, because it's telling me that, okay, it is having, we made a change, right? We changed the material property, and so it is going to reevaluate it for me. And it looks like it's come down now, right? It's kind of let it settle in here as it's changing a little bit here. So there it is, right? It's come down to right around 300 and or 297, 300, around that is what the mode 1 is. And now the engineers, you know, obviously they're telling me that, oh, that's not good, right? I mean, we shouldn't be around 300 hertz. That's, you know, we should be avoiding that. And so now I'm thinking, you know, when I look at this and when I go, I want to, you know, animate this and just see even the mode shape right now. It's also able to provide your deformation. I didn't show you that with the other structure example, but you could have seen the animation, and I could see it kind of breathing in and out in this area. So that's probably what I'm thinking. Maybe around this area, maybe let's, you know, maybe adding a rib might help, right? We'll see how that, you know, that's really giving you an idea about the stiffness too, right? If you think about the modal analysis, the main purpose is the natural frequency, and the mode shapes gives you an idea about the stiffness. So I'm thinking, let me just take off the animation here, and I'm probably going to just see if we could add a quick rib or something in this component and see what happens. So I'm able to go, I can just create a new rib. I can go back to my modeling environment right in here, and just do, for example, I'm just doing a regular profile rib, just like we did with the other example. I'm going to select one of the datums that I have here, right in the middle. I'm going to use my sketcher. I really like in Creo 4, they introduced this clip model in Sketcher, pretty nice, where it kind of clips it temporarily for you. And I'm able to add some references here, right? So maybe I'm going to add a center line, but before doing that, I want to grab some references here. I'm going to grab some of these as well. Let's see if I could add, yeah, there it is. And I'm going to just put a little a horizontal center line up there. We'll just set it to a specific size up there. And now, as I'm in my 2D view, or I could be in any view actually right up there, I'm also able to go add my shape for the rib itself, right? So maybe we'll just give it some distance here. Maybe we'll add our own. I'm doing my regular design work here, as you can see, and that is the advantage, right? I'm kind of, and as soon as I'm done with it, I should get the immediate feedback again, right? So there it is. I'm going to leave it open, and I'm going to just flip the arrows. It's going to be on the inside versus rather than the outside. We'll just give it a thickness here, and I'm done with it. So as soon as I'm done with it, again, it should, the software should go back and recalculate the natural frequency for me, right? It came down a bit, right? Or it's increased, you know, let's see here. It's still, you know, it's still settling. I need to allow it to settle in a little bit there. It's, what is it, 370, 360, you know, you're avoiding 300, but it's still, maybe it could be, now I know that a direction, right, that those ribs are helping. I probably could do additional ribs in here too, right? So I do have a couple of ribs that I've suppressed in here that I've already done. I'm going to resume those guys. I just resumed 2 additional ribs in here, and in real time, it's kind of giving me an idea to give me some confidence of telling my team, okay, will ABS work instead of aluminum, right? It use, you know, it's done as a casting so far, and at least I'm able to use that quick, judgment on will this work or not, right? That kind of. So right now it looks like I've got it up, right? It's closer to 370, if you see the mode shapes, and I can do, I can generate a report, things like that, pretty powerful. But same thing with thermal, right? You can do it on thermal analysis also, right? Now, starting with Creo 7, going back to my presentation here, starting with Creo 7, they did include fluids, right? It's pretty powerful too, wherein in the fluids capability allows you to create the fluid domain automatically. There is a built-in algorithm that automatically creates the fluid domain for you. You could do external flow, internal flow, right? Obviously, it is not as powerful as a full-fledged CFD tool. Again, we want to keep it simple for the design engineer, more of a directional tool to give you quick feedback, right? So when I say quick feedback, again, if I go to my Creo here, and let's say I want to get to another model here. I want to go open up. Let's see here. I'm going to open up another part. This works, by the way, in parts and assemblies to create your fluid domain. In many CFD software, creating the domain itself is a big deal, right? How do you create an internal fluid volume? I have a thermal mixture, maybe I don't know, water mixing. You have hot water, cold. Let's say, and then we do know some inlet velocities. We know the outlet pressure, and we need to see. I'm interested to know the flow, right? What happens inside. So I wanted to look at the temperature, the pressure, the velocity, right, the direction field, etc., and that I'm interested in. And at the same time, I can make some design changes here. So when I go into my live simulation, I'm going into fluid study, right? So that's this can be done only in Creo 7, not available in 4, 5, and 6. And in here, the first thing is you're able to either use an existing domain or use internal domain or enclosure or internal. This is an internal flow, so I'm going to go to internal volume, and I'm able to select the outside surface. So it kind of uses the seed boundary technique behind the scenes, essentially, right? The software has that built in, wherein as I select these 3 outside surfaces, it knows to give me that domain. So if you see in Creo 7, we have the multi-body concept in Creo 7. If I hide the outside design, you see the blue fluid domain for which I will be assigning a material here, right? So let's say I want to go to the fluid domain, and I can just go assign material. And starting Creo 4 itself, PTC has a lot of material library, and now with fluids, they also have fluid library, just a basic air, water, mercury, engine oil, a few things, and you can obviously customize it too. I'm going to just select water right now. It has its properties right up there. And once I assign that, I can just go now and say I want to have a velocity to that. Let's say I want to give it a velocity of, let's see here, we'll just give it about 5 meter per second. We'll probably also add a velocity for this guy here, for this boundary. And I'm going to add a velocity of -15, so it can go inside right there. Y-axis showing up there. And one more thing, if I could go double check this velocity profile just to make sure. I'm going to make it direction magnitudes, direction components. I'm just giving, and then this pressure here, obviously, in the outlet is going to be the atmospheric pressure, right? So which means when I apply the atmospheric pressure is there, so the gauge pressure, I'm just going to give it 0 right up there, right? So it's just the atmospheric pressure. And that's pretty much it, right? I can also, of course, apply a temperature condition here. I could say, okay, this has got to be, let's see here, we'll just give it about 40 degrees C here, and we'll just probably set this also with the temperature of about, let's see, we'll make it hot here, 120. And that's pretty much it, right? Again, there's no run button or anything in here. I'm just saying, let's view. And it's essentially going to give me immediately, right? That is pretty quick for a fluid problem, right? You're not you're not doing your typical meshing, and it's all happening in quick time. It's kind of like in your smartphones these days, the GPU, right? It's the GPU these days compared to CPU. So the graphics cards becomes important, right? There's a utility you can check if you were to get simulation live, just to make sure your graphics card is supporting it, or and the PTC's website has a utility that you could run and you could check what is supporting there, right? So there it is, right? I do have, if I go to my cut plane, I can do other things like cut plane. I could also see the direction field, maybe hide all the results in here and simply see the direction field. I want to have an idea of that, or maybe just look at the cut plane right up here. It could be velocity, right? I could also look at temperature. And right now it's showing me the temperature. So remember the 40 degree and the 120 degree up there. You can see and it's still working on it, right? You can see it's a transient right now. And I'm able to go add, let's see here, I can add a new probe, for example. I could say, let's add a probe to this. Maybe we'll just set this to the temperature to the unit system that I prefer right in here, right? And then because a probe is essentially created based off of that. And I'm going to just do a probe in here. And it gives me right up there, right? The 21 degree, whatever. And it's still settling in, right? It's still reaching that steady state as we speak. And I'm able to go and click on this graph, and it'll kind of show me the change, over time, right? You will see it, in there too. So there are, let me actually, I got out of that one right there. Let me just redo that. And if I go onto the point, and let's say I want to add a point up there, and I want to click on that graph in there, so you could see it's it's a transient analysis right there, and you're able to see over time. It's probably going to come down around whatever 25, 26 that it showed in there, but it's still working on it, as you can see. So just a few examples on how this immediate feedback helps, right? So this is all what we talked about so far is primarily Creo Simulation Live. There are two extensions, like I said. One is for structural thermal modal, but if you need this fluid flow, there is a CSL plus capability, right? So while it's still working on that, let me get to my presentation here. And if I go back to just to talk through the other extensions in Creo, mainly Creo Simulate and Advanced Creo Simulate. But before the Ansys partnership, many of you may know PTC had its own solver, and that it is still there, right? Very powerful. I've used it during my industry days myself. There's two versions or two license options, Creo Simulate and Creo Simulate Advanced. And they're very accurate, and has large deformation. It has vibration analysis. You can do nonlinear contact. So there are some additional capabilities compared to Creo Simulation Live, but it's for a different use case, obviously, right? You want to do that higher fidelity, more accurate analysis with certain capabilities that are not yet available in the Ansys products in there. So again, those who are using Creo Design Essentials right now, the base license, you do have a little bit of static structural analysis, automatic meshing, results reporting on Creo Simulate, but then Creo Simulate Extension and Advanced Extension gives you some additional capabilities, right? So the main reasons you might want to go to Advanced Simulate Extension is you have transient thermal analysis, you got dynamic analysis, which means you can mimic like the shaker table test in the real world, the high-end vibration analysis. Maybe you have a PSD, a power spectral density plot, G-square hertz, and you want to see the response of the system, right? You have nonlinear materials. You want to go, mimic rubber or elastomers, for example, elastoplastic materials, or maybe hyperelastic, I should say, and also elastoplastic if your component is going to be permanently deformed. That would be a nonlinear material with large deformation, contact. All those could be done inside of Advanced Simulate, right? So there's a main capability, like I said, for Advanced Simulate Extension is the complexity of the analysis when it comes to assemblies with contact instead of simple bonded, right? With Creo Simulation Live, yes, it works great, and if it's bonded, and it's always stuck together, but in reality, you're going to have friction, and you might want to assign, it could be a sliding contact situation where you want to know what is the minimum force required to pull it out or push it in, or you're interested in the threads failing, in this example. So for those, you would need Advanced Simulate Extension, right? Including, you might have a situation where, like this stapler pin here where it's permanently deformed. So I need to assign a different mesh, maybe a brick element for those areas that go beyond yield, right? I might also want to assign my true stress strain curve for the material to better mimic that elastoplastic behavior when the material goes beyond yield, and have better mesh control. So this is the traditional, old Pro Engineer used to have Pro Mechanica, now it's called Creo Simulate, and the Advanced Simulate has these additional capabilities in there, right? So one of the biggest advantages, before I show you a quick example on Simulate, is the technology itself, right? If you look at the traditional finite element analysis, which is typically most of the softwares are H-based, the mesh density plays a very important role in the accuracy of the solution. In other words, the experience of the user plays a very important role in getting accurate solution. So I have a simple cantilever beam situation here. The finer the mesh, the more accurate is the answer and less is the error. So if I were to compare this with a hand calculated result that I got for a beam of that size and models of elasticity, you get the max deflection and the max stress. You could see when I run it using the software, the higher the mesh density or the degrees of freedom. So with 40 mesh elements, you see I got a huge error, but with close to 1,500, I'm getting there, right? I'm not yet there, but maybe a couple more passes and I might get there. So that's a traditional method where the user's experience comes into play. And that's why the so-called expert that I mentioned, one of the barriers in FEA is experts know, right? Many times we look at a model and we know, depending on the aspect ratio, how much we should be refining it. And that's been the cornerstone of H method experts, FEA experts, right? They always rely on their experience and they have to keep refining the mesh. Or nowadays they're automated. At the same time, it requires a lot of experience, and that's why it's a specialized field. You do a lot of pre-processing. Creo Simulate uses P method and not H method. P stands for polynomial. So if I were to ask you to really, on a simple part like this, run an analysis in your traditional FEA, you would go and add more refinement, since most of the softwares use linear equations or quadratic equations to solve. However, when it comes to Creo Simulate, it can solve that with a larger number of elements. The reason is when I'm going to push this plate on either side, the deformation, I know I'm just exaggerating it, that's kind of it's going to behave, but I'd like to have that deformation using a higher order polynomial. So the software uses adaptive method where it uses up to 9th order polynomials to converge on the solution, thereby reducing the user's experience. So the burden of getting accurate answers transferred from the user's experience to the math built into the softwares. And that's kind of why Mechanica and Creo Simulate has been so popular within our customers for such a long time, right? And it's still there, all right? As you can see here, the first pass, the way it would typically work is if I were to graph the von Mises stress or deflection versus the number of passes it's doing automatically, the first pass uses a linear equation, a linear shaped function to solve. Then it uses a quadratic equation to solve, and then it compares the results or the delta, the difference between them. If that's less than a user-defined percentage, it'll tell you that's your answer. If not, it keeps doing this automatically. So just the opposite of what they do in the H method. Instead of refining the mesh, we are essentially keeping the same mesh, but elevating the polynomials used to calculate those shape functions. And that's more geared towards less experienced design engineers or engineers that they don't have to spend a lot of time on refining the mesh, and they still get an accurate answer. And that 9th order polynomial is when it gets the accurate answer. If it didn't get there, if I'm getting a graph that still keeps non-converging, I do have options to refine the mesh if required, but it's always a last resort and we don't have to do as much. So that's one of the big things about Creo Simulate, where it uses the polynomial method for convergence, okay? And it also gives you the nonlinear capability. So some of the big, huge benefits of Advanced Simulate is that it can handle large deformation analysis, where you apply a load and then you see the maximum deflection go even beyond the thickness of the geometry. That calls for a totally different theory, right? Your classic plate theory and everything based on which FEA is written goes out the window, and that's why we call that as a large deformation analysis. And then hyperelastic, elastoplastic materials, right? Permanent deformation, or for elastomers or rubber parts. And also contact analysis, right? When you have two parts in contact, depending on the stiffness of the two parts and the load, your area will go non-linearly. It will vary, based on the load, and that would be a non-linear analysis. So this is an example of where I have large deformation and I have contact. At the same time, I have plasticity, wherein the material is yielding, it's going beyond yield, so there's permanent deformation. So all of this could be done in one go inside of advanced Creo Simulate, right? So it can handle large deformation. So you could go from linear, which you can do in regular Creo Simulate extension, but if you want large deformation, elastoplasticity, contact, and combine all of them, you could do that with advanced Simulate. So here's an example where I know there's going to be permanent deformation, but for permanent deformation, I don't want to use my regular tetrahedron mesh. Brick elements work better. It's a good practice to have brick elements when you have permanent deformation, or when you go into elastoplastic area or beyond yield. So I'm able to determine and also define my mesh and say I need to have brick elements in order to mimic this behavior, or better get an accurate solution for the post-yield behavior, right? So again, contact analysis, hyperelastic materials, they have several models that are supported right there, right? You're able to assign the test data, the true stress strain data, and the software picks up the best, your material coefficients based on the minimum RMS error, right? These are predefined inside the software and picks up the best one based on the least RMS error. Same thing with elastoplasticity, right? You have linear hardening law, power law, exponential law. It's able to pick up the least one. So you see how we started off with a very simple part earlier, and then now we're talking about the higher end FEA, right? So there are different, this is the main reason there are different solutions, obviously, right? For the higher end FEA, as well as for a quick directional tool, there are different extensions inside of Creo, right? And lastly, if you want to do vibration, right? Some of you may want to mimic the real world shaker table test inside of Creo Parametric, and you have an assembly or a component. Maybe they're asking you to do a half sign sweep test, right? That they do, in the auto industry, that's a huge thing, right? So I have to, instead of, you could just mimic the real world shaker table test by applying a time dependent load, a frequency dependent load. And you can also apply like an accelerometer, right? You could create a probe and even compare it with real world accelerometer readings to kind of correlate that, to give you that initial confidence, as well as dynamic random and dynamic shock. Dynamic random is more for PSD, right? Power spectral density plot, mainly used, in the aerospace industry. It's huge, right? That's where they might say, okay, you want to make sure that this will pass this PSD, or they will give you that G square hertz curve that you need to pass, and then you can test the response of the system. It's more like a probabilistic study than a deterministic study, dynamic random. And you can also mimic, earthquake seismic analysis, right? Where you might want to, again, depending on where you'll be installing your equipment, in which geographical area, there are different curves it has to pass through, and that would be dynamic shock analysis, right? So really there are 4 types, dynamic time, frequency, random, and shock when you do these. And really quickly, if I could go back to Creo, and let's see if I could close out of my Creo right up here. And while it's doing that, let me get to actually right up here, and the capability comparisons, what I wanted to kind of quickly wrap up with. So we talked about Creo Simulation Live right up here, right? This is one thing I showed quite a few examples. And then we talked about Creo Simulate extension and advanced extension, right? So these two in here. So you could see that from if you look at pure powerful nonlinear capabilities, then right now, Creo Advanced Simulate Extension can do all of those that I talked about, right? Nonlinear contact, nonlinear materials, etc. And there is this Creo Ansys Simulation, right up here, the second column, that has some additional capabilities compared to Creo Simulation Live. Both these are Ansys powered, right? These two solutions right up here. And both these, the third column and the fourth column, those are Creo's own P-solver. So you can see a quick comparison depending on what you want. But the key thing about Creo Simulation Live is real-time feedback. Instant feedback is the main thing for Creo Simulation Live, right? For advanced simulate extension, it's more nonlinear capability. Your typical CPU-based software, it handles assembly context better, right? It's not a direction tool, it's more for a final validation there. So you have those different extensions in there. So with that said, let's see if we have any questions in the questions area as we come towards, I got like 5 minutes left here, but if you have any questions, please start typing in the questions area, and I'll try my best to answer them as they come there. So just give everybody a minute here. Okay, so it looks like there are no questions at this point. Just a quick a reminder here, if you want to view these webinar recordings, including today's recording as well as previous webinars we have been doing, if you go to tristar.com, you could go to webinar replays under resources, and you could search for the webinars. You also have the events, and you can also register for upcoming webinars as well, right? And just a quick reminder on the time limited offer that will expire the end of this month. All Creo extensions, when I say Creo extensions, any add-on extensions that you currently don't have, it could be advanced assembly extension, it could be ISDX, it could be additive manufacturing extension, it could be topology extension or the new generative design extension. All those extensions are 35% off, including the simulation extensions, both the Ansys powered as well as the P-Solver Creo's own Creo Simulation extensions, including Simulate and Advanced Simulate extensions. Okay, if you're interested, please reach out to your reps at TriStar or visit tristar.com. All right, and you can reach out as tristar.com or call us at 800-800-1714. Thank you for taking the time. I hope it was informative to know about the current simulation tools inside of Creo that are integrated to Creo. I really appreciate you taking the time to attend this webinar. We look forward to seeing you soon in another webinar. Until then, all of you have a great rest of the week, and thank you.